morning. Good morning, everybody. Welcome to this session. And what we're going to talk about this morning is what is in data for facilitators. And the question is, does data mapping always lead to diminished data quality? That's the answer. That's a question that we have to answer this morning. First of all, let me congratulate again the organization, all the people involved in this magnificent, outstanding event. And we had some change in the program. The facilitator, the president, was supposed to be James de Clark, but unfortunately had an unforeseen situation and had to return to his country. So my name is Delfim Rodrigues. I'm a Portuguese, I'm an health administrator, and currently nowadays I'm the coordinator in the National Health Service, in the Portuguese National Health Service for hospital at home. More and more we are treating people at home instead of treating them at the hospital wards as usual. I'm not talking about this today, maybe another time. But to say that my day-to-day routine, and also in a more time span strategic terms, I also act as a data facilitator, namely in telemedicine, and we use and increased very much, as you can understand, during the pandemic period, particularly during the peaks of the pandemic. With no more delays, today we have 4 speakers, and we will be starting by Christel Daniel. And in order to get more acquainted, I won't be making presentations of the speakers. Instead, I'm going to ask each speaker before the presentation to present themselves to the audience. So, Christel Daniel, thank you very much to be with us. You can start by presenting yourself, what you are doing nowadays, and after that, proceed to your presentation. Thank you very much.
Thank you for the introduction and for the invitation. So, I am Christel Daniel. I am a pathologist by training, and then I am the associate director at the Innovation and Data Department of the IT department at Assistance Publique Hôpitaux Paris, which is a network of 39 hospitals in the greater Paris area. I am also a researcher, and my domain of expertise is clinical research informatics and clinical data warehouse. So in this talk, I will first explain how we understood the question, and then see how far data mapping leads to diminished data quality, and then how much data mapping can also lead to increased data quality, and conclude with some thoughts about data mapping, data quality, and fitness for purpose. So first, how do we understand the data facilitators? In our hospital, we can consider that data facilitator can be data owners, data stewards, data custodians, and data processors. But regarding the question and the issue of data mapping, we will focus on the data stewards who are responsible for what is collected and stored in information system, and also data custodians and data processor that who are working in IT department and are responsible for the infrastructure, the technical environment, and the database structure. APHP, as I already mentioned, is a network of 39 hospitals and integrating 6 university hospital groups. And in APHP, we have been deploying a common electronic ASCII record since 2012, and I led the team who deployed the common clinical data warehouse since 2014. So this clinical data warehouse includes the data from 11 patients, and it includes administrative data, medical economic data, clinical data, and also data from exposome. And here you see the data production and curation life cycles in our hospitals. And in fact, the data facilitators are performing mapping all along this data flow from the data sources through the data lake, through different data marts, including a data mart dedicated to research. And then through the process of delivering data set in research working spaces. And the data mapping, as mentioned in the questions, are performed at different places. First, within the data sources, because data stewards are standardizing some data at the point of care when they are collected, and then they perform a mapping within the primary ETL process from the data sources to the data lake, and they also perform mappings between the data lake and the data mart dedicated to research. And in our hospitals, we decided to integrate the data for research using the OMOP data model provided by the ODC community. And then they also perform mapping when they set up the standardized access to the data. And in fact, we are using Fire API when we deploy our cohort builder. The cohort builder in the hospital is called the cohort 360, and it is interfaced to the research data mart through Fire API. And then mappings are also performed in the working space that are open and to the research teams, and they perform different processes, different activities for data curation in their working space, including mapping. And then to understand the question, we also share with you how we understand data quality in our hospitals. In fact, data quality can be understood very differently because in fact, the real-world data repository have different models of governance, and the data custodians apply very heterogeneous processes to ensure data quality and fitness for purposes in their hospital. And in fact, there is no clear conceptualization of the intrinsic and contextual determinants of data quality. So at APHP, in fact, our understanding of data quality relies on the harmonized framework provided by Can and collaborator that has been published in 2016. And according to this harmonized framework, we can consider three different data quality categories: conformance, completeness, and plausibility. And they advise to define data quality checks into two data quality assessment contexts: verification and validation. Verification is when the data quality check refers to internal knowledge, and validation when it refers to external knowledge, and we also refer to the extended version of this harmonized data framework published in 2021. And also, since we are implementing the OMOP data model in our research data mart, we refer to all the processes and the tools developed by the ODC community. Then to answer the question, I will first try to illustrate how we can consider that data mapping leads to diminished data quality. I will use the example of the lab tests in our hospitals and the mapping to LOINC. In our hospitals, we are using for lab test local coding system called Anabio for the lab test results. And we decided to use a local terminology and not directly to use LOINC because of an insufficient coverage of LOINC, and because we have to handle lab test with higher granularity than what we can find in LOINC. And because we need some complementary specific attributes that we cannot find in LOINC, and we need to have French labels and flexibility since we are creating a new lab test over time. And then, but we regularly map our local terms to LOINC to perform semantic interoperability. And in fact, 64% of our local codes could be mapped to LOINC, and with a different rate according to the domain in biology, but saying that in fact you can see that we cannot map all our lab test costs because of lack of resource and time, because we are creating over time more and more codes, and also because there are some delay when we request new codes from LOINC, from the Regensriff Institute in charge of LOINC. There are some delay in their answers. And but what is nice is that when we are considering the top 4,000 codes in our hospitals, the mapping rate increased to 93%. But you can see that there is a remaining number of lab test codes that cannot be mapped to LOINC, but some of them are intermediate analysis or include comment or interpretation that may not have a big impact on secondary use and research. But you can see by these examples that yes, the mapping to LOINC in our hospital leads to diminished data quality in that sense that it decreases the completeness. We have missing lab test results. But as you have understood, it does not occur for the most frequent lab test results. And due to face this situation, the corrective action that we can take is that first the research teams in their working space, they can use the local terminology if they are involved in local APHP research, and if they are in an international context, they can provide additional mapping, approximative mappings. But in fact, taking the same example, we can also say that data mapping leads to increased data quality. And I will take the example of what has been done in France during the COVID-19 pandemic. During that time, in fact, there was a recommendation to use LOINC at national scale, and for this very precise data set of lab test result involved in the COVID-19 diagnosis, there have been great incentive to laboratories to encode their results using a minimum set of LOINC codes, and also to encode consistently the results of the COVID test, negative, positive, and undetermined, using SNOMED codes. And then in that example, in the same domain, mapping to LOINC, you can see that in fact there is an increase of data quality, in the sense that there is an increased conformance of the results in this context of the national COVID-19 screening program. So you can see that when there is a large adoption of a common data model, in that example, it was HL7 messages, and the common adoption of the related value set, there is an increased conformance without any decrease of completeness. But due to a comprehensive mapping of all the COVID diagnostic tests. But we can say also that this result is achievable because we are focusing in that situation on a very limited data set. So that means that when we define high value, we can build high value sets, since we are focusing on limited scopes. So then for I will try with 3 examples to explain how we could perform some data mapping without losing data quality. So the first example, always in the same idea. Sorry?
Maybe you can resume in 1 minute, 2 minutes.
Yes, of course. So my conclusion is that if we can focus on the minimum data set, it's possible to achieve some mappings without losing data quality. And very quickly, I will go through 3 examples. The first example is that in France, we defined the minimum data set in the laboratory domain. And focusing on that minimum data set and using a common data model HL7 v2.5 or HL7 CDA, it's possible to achieve high quality value set in that domain. The second example is the Penelope initiative in French. It is an initiative aiming at matching eligibility criteria to patient data. It's another example in which we define the minimum data set for this pre-screening process, and we also define a common data model, which is a OMOP, and it's versions 5.4 dedicated to oncology extensions. And since we define this minimum data set, it's possible to build high value, high quality data set to address this use case. And my last example is in the context of pre-populating ECRF, clinical research database with data coming from the electronic healthcare record. In that context, it is much more difficult to focus on one data model because in care we are using FHIR and in research CDISC is used. But if we, once again, if we can focus on the minimum data set, we can address the mappings, the different mappings that are needed. So my conclusion is that data mappings do not always lead to diminished data quality. If we can select a common data model that is relevant for the use case that we address, and if we focus on minimum value set to address the interoperability and data quality challenges. But one of the issue is to find the resource, the quantitative and qualitative expertise to provide high quality mappings. Thank you for your attention.
Thank you very much.
To my person, I'm also working as a board member for the ITTM Transplant Foundation. I'm part of the ADEX here, Industry Advisory Committee. My background is being a molecular biologist, a genetics guy, working in virology, but moving into pharma, bioinformatics, medical informatics. It's a mixed bag in the end of the day. And it's not working with this. And it's not working with this.
Maybe with the keyboard itself.
Okay, so let's see the keyboard.
Yeah.
Okay. So I said we are switching gears a little bit and destroying the room. You heard yesterday Ricardo also talking about Smart for Health, and this is a very nice project. And ITTM again also has the honor to be part of that. And you see the logo in the middle of this. And what I want to show here is as well something which derives me always. We are generating data again and again, which are actually already generated somewhere else, and we are not reusing it in a meaningful way. Obviously, because sometimes the formats are not there, the data is not being collected in exactly the same way, etc. But if you're looking at the landscape, and I took this picture from a German organization called TMF recently, you have data with the researchers, obviously, but also with the citizens, with the healthcare providers, with the health insurance. You could reuse in a meaningful way if there's a standardization, if there's a data access possibility. And I think one of the aspects we, as data facilitators or SMEs or organizations helping the data generators with that, we will play a very important role in all of that. And there are some thoughts I put on the slides here, and this is basically the data used in clinical studies or in care. Are they actually the same? They should. But I think there are many examples where you look at the files of the GP and you look at the files of the electronic health records. Well, are you born? Yes, that might be correct, but some other aspects might be missing. There is a legal aspect, and I'm certainly not going into details on that. Depending on if it's a study, you have a consent. But if you're a provider, you might have a contract to store the data, to do whatever it's being possible to do with the data. More and more increasingly important are patient-reported outcome measures and variable information. Yes, this is not maybe medical grade, but it gives an information if a person is, for example, moving, is active, or is just a couch potato. The aspect of episodes and longitudinal data. Well, I'm luckily not every day in a hospital, but you might want to have longitudinal data in order to understand the disease much better. So where it's coming from. So is it really only the EHR where we have the information, or is it being in a registry, or is it actually being at a GP? Or, we have to bring this in a clever way together. Not to forget discrete and streaming data. Again, is it really important to know how many steps I do or that I'm moving? Is it important to have the, episode, the picture of a movie, or do we understand the movie only if we look at the full thing? Well, there's also the point I put in yesterday evening saying, do we say interoperability, or do we just copy yet another version of the data, modify it, clean it, and then use it? And a friend of mine who's working at the University of Vienna has just got a grant talking about digital waste. Do we really need to store all the information we are capturing? How much energy and cost are we creating by just making copies of copies of copies? We're, taking up space somewhere in data centers and basically are meaningless. It might be a thought for thinking. Obviously, data protection, privacy by design, processing, that's something which is important. So let's see if I can do it this time better. Yeah. This picture I basically took from a recent publication which ITTM we were able to do with some folks from the ERS, European Respiratory Society, focusing on severe asthma. And what you see on the left side, obviously, is it's a typical process. You have a characterization, you have a starting point, you have a characterization, you do the mapping, you do the ETLs. And what I put in here, and this is sometimes forgotten, but I guess everybody has this blue elephant. When you're running into ETL problems, is it because the SME or the data scientist did a bad job, or is it because you figure out there's something in the data which should not be there? So the aspect of data curation, we are not being paid for that or being reimbursed, but there is an active data curation if you're running this with the OMA common data model, etc. pp. And that can take a lot of time. It's not meant that it's being bad, you have worse data. It is something which we have to consider. And that, we talked about this morning, has to be fed back to the registries, because otherwise, next time somebody's asking the data, you do this data curation again and again and again. And I think this is something, again, where we can reduce costs, reduce efforts in a meaningful way, because that is a time and resource consuming process, which is not fun in the end of the day as well. And then if you have the common model and we have the data, we can analyze. And here, why I'm bringing this up is we are talking here small registries in different nations around Europe, which would wanted and pharma industry was interested to do studies with. But by individual size, they were too small in order to get the numbers for the power of analysis. But being together as a group, having the common data model, they got enough power to do the analysis. And what is really fascinating here as well is they realized, even during the data curation, it wasn't seen, but some variables were measured simply in a different way. They agreed on, yes, the variable is important, but one said it's a category, yes and no. And the other registry said, well, it's 1 to 5 because they're coming 5 times. How do we, and we triggered by working together with them, the process of harmonizing also the way data is being captured in the registries in order to enable, which is again something which I found very, very interesting and great because it really facilitates connectivity and collaboration. Again, where can be a data facilitator? I'm sorry that the titles are being hidden. Where can a data facilitator, an SME, whoever you want to embark on it, support? And it's actually everywhere. In this project I just showed you, we were supportive. Thank you. We were able to help in all steps, talking to the legal teams, making sure that they understand it's not a physical transfer of data, it's actually data use and access. To the IT people as well, what does it mean you have a normal database next to your original data? What is the use and access you need there, because you need some holes in the firewall, etc. Obviously as well, training the people, what does it mean? How do you use it? Mapping, maybe train the trainers. Again, we heard this morning what Eden is doing with the academy. It's a great job, but let's be honest, it's a starting point. It's not final. You have to do more. And I'm pretty sure there will be a master class or more training to keep. And there's also here an anecdote maybe. We went there as a consortium with 3 companies. Yeah, with 3 companies. And we choose one person to do the mapping of 10 registries. By that, harmonizing the way we did the mapping. Looking into other projects where we have 10 people doing the mapping, well, we have some flexibility in how to do this. It's not being done by me alone, obviously. It's, as I said, a young company, 15 people right now. I really, really like to thank, again, them and us that we can do this. And if you're interested in ITTM, we started some 7 years ago with pure data management curation questions. We are now more in this digital health services. And I'm really glad also, again, being part indirectly of the Eden community family. Also with two other projects, the EU Pearl one, which is looking more on the analysis, on the phenotype, how can we really run this? Optima, T2 Evolve, two projects which are really going to use the OMOP Common Data Model in a hard way. But on the other side also Smart for Health, Digital Skills for Health, and the Parkinson Net in Luxembourg are projects where this is really, really going nice. So thank you for your attention. I hope I'm kind of in time. Sorry for the technical problems. It's me. Sorry.
Thank you, Andreas, for this inspiring moment that you shared with us. And we are short of time. We move immediately to Miriam Sturkenboom, please.
So let me start introducing myself. As I'm here, I'm a professor in real-world evidence. I have been working for 20 years at Erasmus with colleagues in the room here, Peter, and since 5 years I'm in Utrecht, head of the Department of Data Science and Biostatistics. So I hope it's clear. So also for me, the question, what do we lose when we map data? Do we lose quality of information? And the view I'm going to give, or the perspective I'm giving, is from a medicine's real-world evidence generation pipeline. So my background is I'm a pharmacist, epidemiologist, and work from that perspective. So what should I do to move? Yes. So I just want to take you back, because we're also talking about value, why we actually are in this situation in this from the medicine's perspective. And I would like to take you back to Rolf Koch's story in 2004, which was a medicine, a novel NSAID that actually was on the market for 5 years when people discovered it's actually associated with myocardial infarction. So that scandal then again took the Institute of Medicine to reevaluate their pharmacovigilance systems. And it was actually Rich Platt, who is now running the Sentinel system, who calculated if in the US they would have monitored 100 million people, they would have discovered a signal within 3 months. So that was the reason actually for the FDA to create the FDA, or to push the FDA Amendment Act, where they made it obligatory to follow these persons, the health records, and to do monitoring of safety of medicines. So that led to Sentinel. At the same time, there was the OMOP project. There was subsequently there was C-Notes initiative in Canada. Darwin now in the EU just recently, but there have been many projects in the EU, coming towards where we are now. What we used to do before, and this was common practice, and here is a nice meta-analysis. Maybe we can move this below again. I just shift it? No. Yeah. Good. All right. So we used to just meta-analyze data. So everybody would do his own study that would have its own database, would conduct a protocol, or would have a protocol, conduct their analysis, and then when they were published, we would meta-analyze it. So that was practice until the start of all these multi-database collaborations. All right, so what is the value of having discovered that there could actually be better collaboration? It's all of these networks that have appeared. We have heard about Odyssey, about Eden, Darwin. There are other networks like the Nordic Pharmacoepidemiology Network, Vaccine Monitoring Collaboration for Europe, Sigma, and a lot of people realize that it's good to work together to generate evidence. Now, in this realm, from the regulatory medicines perspective, there are also 2 quality guidances that are out there as drafts. I think everybody now realizes there needs to be quality guidance. So there is one from FDA from September last year, and EMA also released a data quality framework in September this year. Both of them describe all the elements that need to be there, which are very, consistent with what you would do as an epidemiologist. But they also require really the Q&A and the QC part, as well as the documentation of data management. So EMA is closing its comments today. So if you still want to look at it and provide comments, I think they would be happy. What is important, I think, for both of them, that it's not just about a threshold of quality. It's not about 80% completeness or, fixed numeric thresholds. It's really that they would require that per use case, so per application area, you assess actually whether data are fit for purpose. So it's not a easy cutoff that we can utilize. It's really depending on the kind of use we make for it. So we have heard a lot about the OMOP Common Data Model, and I guess many of you are part of Eden or Odyssey community or working on an SME. But there is another common data model that has been developed in Europe as part of the IMI Conception project, which is a project that is participating with 88 partners to actually generate better evidence of medicines in pregnancy. And when we started out, we did an evaluation of all available CDMs. And at that moment, we realized we needed to create our own CDM because the current ones were not complying really to do easily medicine safety in pregnancy for the details. So that's why the conception CDM was developed. It's being utilized now in a large number of networks also to conduct studies for the EMA. Now, what is the difference? So the key question is why did we do it? What is the difference? And I will try to initiate that debate a bit because I think it has to do with quality of the information. So the key difference, I tell you now, it's like how many steps you take to harmonize. So here I try to put, here we see the OMOP Common Data Model. So I hope this is the latest version, but you see all the clinical tables on the left, the standard clinical tables. And if you look at the Conception Common Data Model, they're very similar clinical tables that are being utilized. It's not that the difference. What you see is that there is a lot of vocabularies being utilized in the OMOP, and we heard this morning also from Peter that, that there is a large amount of vocabularies that need to be maintained. And actually in the Conception Common Data Model and pipeline, we don't use all those vocabularies. Actually, the semantic mapping, which is step 2 in a mapping, is done as part of a script. It's not done up front. So I would like to walk you through that. So the entire semantic or the dealing with differences between data sources and heterogeneity is part of the study script actually. So this is how we lay out our pipeline, and I would like to advocate for the fact that we need to build pipelines that actually are able to ingest more than one CDM. So not, not map everything to one CDM, but have a pipeline that's able to ingest both FHIR, whatever CDMs that can actually be. So the typical ones, the typical steps are that data are local in their current formats, and then we need to take this first step. It's a transformation step, which is the ETL that we have been discussing about. And what you end up after the ETL is a syntactic transformation. So that's step number 1. It's the structure, at least the table names and the variable names are the same, which helps a lot if you want to launch a program or a script, because you need to know what to program towards. Now, the second step then, and I think this is what we have been hearing, is the semantic harmonization. And this is what, in reality, dealing with the heterogeneity that exists in Europe and across all of the data sources is a tremendous effort. And we have heard that also this morning. So our pipeline currently is actually doing that semantic harmonization as part of the study script. So it's flexible, it's scalable. You maintain all your phenotype libraries for the next time around. You can create algorithms that get tailored. And I think because this is being done in the script, actually the data access providers are able to onboard very rapidly. So they only need to do the ETL. It's much faster. So I would like to discuss that actually. Now, what then is done, once people have transformed their data in the common data model, there is a lot of quality checks being done. So it's either the completeness of the ETL and whether the ETL went okay. There is the accuracy, plausibility, and also an assessment of whether the data is fit for the study per se. So really on a use case per use case basis, you assess whether that data source is able to participate. Now, the input for the semantic harmonization is, of course, a phenotype library with code list algorithms that you need to maintain. So if you look at the pipeline, I go one back. So clearly, all of this needs to be documented and with metadata, and all the guidelines already, or the guidance documents require that. So there's also a document out for metadata for discoverability, to create a fair data catalog. Okay, I go. And so maybe just to, maybe I go to the example. So this is the process of the mapping of the semantic harmonization for events. I mean, this is one mapping, I think, in HOMOP. The way we conducted in our pipeline, we also use the UMLS to do a cross mapping across all vocabularies, and this is ingested in the program as the semantic mapping. And then the question, of course, is, does it matter which approach you use? So is there a difference? So I take here an example from recently conducted work for the EMA, which was to calculate COVID or ASI background rates. So here, so here is narcolepsy. So here you can see the incidence rates that from the Odyssey publication, with a difference between data sources of 100-fold, and in the conception pipeline, there was a 7-fold difference, which was completely explained by the provenance of the data. So my summary, common data models help. I think they help especially to get an insight in the quality of your data. As Peter stated this morning as well, many databases otherwise do not even know what it is, so we completely align there. But there are 2 steps of harmonization necessary, and I think the key question or the discussion item would be whether really you need to do an upfront semantic harmonization, which costs a lot of time, or whether you could actually go to a pipeline that conducts that as part of the study to be faster to onboard. So I would like to say that.
Thank you very much.
Any questions, or should I?
No, but maybe by the end of the session, if we got enough time to respond to questions. So we move to Maxim, please.
Yeah, thank you.
Last speaker.
Yeah, and so you have 7 minutes until the
Last
coffee.
speaker, last time.
Sorry, which one is?
I think you already moved to the desktop.
This is it.
Ah, yes, it's the top one.
The top.
Yeah. So I'm Maxim. I'm a data engineer, I would say, and I've got many years of experience now with harmonizing data, specifically the OCDM. And I recently started as a researcher as well in the Erasmus Medical Center in Rotterdam. So this actually ties in really nicely in both the main session of Peter, zoom in a bit on one specific aspect, but also in the conclusion of the previous speaker, actually, because I'm not going to answer the question whether harmonization increases or decreases the data quality, but I fully agree that it gives us insight in the data quality by harmonizing data, especially when working in a network of databases. So I'm going to talk about the data quality framework implementation in Odyssey. It will be more a bit of a technical talk on how did we implement, specifically in Eden and Odyssey, a data quality framework so we can get an insight in its data quality in a network of harmonized databases. I'll make this very brief. So the OCDM, Miriam already showed it. I think this is a slightly different diagram indeed, but basically the same. Important indeed, we have a structural harmonization and the semantic harmonization indeed up front. And on top of that, the Odyssey community has produced a library of standardized tools. And Eden, Peter already talked about Eden quite a lot. What I want to mention here is that all this work I'm presenting is actually produced the work of the Eden consortium. It's an IMI funded consortium together with the Odyssey community. I'm actually not the main developer of this whole framework. I am a very active user of it. So what stages to assess data quality? Of course, at the source. Let's see if we can move this.
I will try.
There we go. Yeah, that's what I wanted. So of course, we need to assess the quality of the source data, the quality of conversion, but I will zoom into the quality of the harmonized data. And that actually also gives us insights in the processes before that. So that extends to that as well. Framework of data quality also has been mentioned a few times. but I will go into detail now a bit on how we implement the data quality checks in each of these categories. So with conformance, so how well does the data adhere to this, in this case, the OMOP common data model. We have completeness, so are the required fields provided, and plausibility. So given certain ranges of the data, is the data within those extremes? All right, so a practical example. An example of a conformance check is how we can apply that in the OMOP common data model. We can check for the number and percent of records that do not have a standard valid concept in the gender concept ID field in the person. So we one particular check that we do in this case, a particular field in a particular OMOP table. Now we can parameterize this, saying records that have a standard valid concept in any CDM field, in any CDM table where we expect such a standard concept. And this, in this quality framework, we call an is standard valid concept check. An example of a completeness check would be the number % of distinct source values which are not mapped into a standard concept in the condition concept field of the condition occurrence table. Again, we can parameterize that, and then we call this type of check the source value completeness check. And lastly, an example of a temporal plausibility check, where we check for the number % of records with the value in the year of birth field in the person table less than a particular value in this, 50. And again, we can parameterize that. This is the plausible value load check, to be precise. And this can be applied for this temporal check. We can also check, of course, for particular ranges of measurement values. So then we have these templates, and actually we have many of these templates, 20 check types over these particular categories of data quality. This is quite extensible as well, so we could add new check types. In the way we implement that, in total there are 3,500 checks divided like this among the different categories. You see a lot of checks are actually in the possibility category because for every different concept, every different diagnostic code, for instance, you can define a different possibility check. Then how to decide that the results are good enough? So how we phrase each of these checks, it's actually just counting the number of violating records or the percentage of violating records. So that's actually the result of each of these 3,500 checks. So we need to apply a certain decision threshold to determine whether this particular check failed or not. So it could be that it's 0.01% of records that have a hemoglobin A1 % where the value is lower than 4, the middle row. That might be fine. So if it's below 5%, we're saying, well, okay, that's fine. We report that there's violating records, but we're not failing the check. But the last one, actually, there we can say it fails because it's above this threshold state of 5%. These thresholds can be adapted. So this is basically the framework. And this has been implemented in a piece of software, the Odyssey Data Quality Dashboard. This is an R package, so developed by the Odyssey community in collaboration with the EDM Consortium. It's an open source R package, and it implements all these standards, the whole framework that I just presented. This is an output dashboard. Won't go into details, but it will show you how many % of all these more than 3,000 checks fail your thresholds. This is roughly what it looks like. So it's a very extensible framework. The input is this list of templated checks and the list of thresholds per check. That's then run on the harmonized data in the OpenCDM. it will produce machine-readable results that can be loaded and can be shared over the network, these results, and can be loaded in a viewer. And this is a more detailed view of just 5 of the output checks, very similar to what I've shown before. And I just want to highlight, yeah, it's really small to read, but just to highlight that sometimes you can expect for a particular database that a check fails. And this is important to understand. So in the Eden and also now in Darwin, we evaluate these results per database, and this helps us to gain insight of the quality and the characteristics of the particular data source. For instance, the topmost check here, where 46.8% of the records fail this check, or violate this check. Sorry. Yeah. It says that the number % of records with a date value in a drug exposure and date field of the drug exposure table that occur after death. And this is actually something that we see a lot and is somewhat expected. And this is a great insight we've gotten, that drug exposures or prescriptions are often ending either in the future or after the death of a certain person. And you might have an idea of why this occurs. Because often prescriptions are written for a certain period and don't take into account future, or it's actually written and will end in the future. And this could be after the death, actually, or the death happens during the prescription. Now, you could argue that this violates for 50% of the records might be a bit too much. And that then triggers some investigation in this particular data source. Skip that. So this is actually my last slide, but actually the main takeaway here, because we have applied this framework in the Eden network to improve the data quality or get these insights in a network of databases. So I applied this for 15 databases, and we looked at the results. Because it's an iterative process, we applied the data quality test after the first ETL, after the first harmonization phase. And we see the percentage of passing checks there on the left for each of these data partners. And then we also, after a number of ETL iterations of improving the data quality, improving the harmonization process, then we also applied the same metric, this data quality dashboard, on the final data set. And for all data partners, we've seen an improvement, which makes sense because we use these results as feedback for the data partners to improve their data mapping. So that's actually my takeaway message, that using this harmonized data and standardized tooling, we can get insight and improve the harmonization, the data quality, especially in this network databases. Thanks for listening.
Okay. Particularly your takeaway messages. Well, we are running late 4 minutes, but anyway, we have time for 2 questions. $1 million questions, please. Anyone can take your risk. Please.
We have seen 2 different approaches, and is it the basis of the difference between the approaches, the burden of harmonization? Where does it lie in the process? The providing of data by the facilitators, or do we require the facilitators to do the harmonizing effort already from the start? That's the difference, I suppose.
Very, very nice question. Thank you. Anyone who would like to answer?
Well, the answer is yeah. What is it? For a study, you can get rapid, probably more rapid adaptive, recruit facilitators.
It's in where you put the burden, at the harmonization process or at the study execution.
I also think that one doesn't have to exclude the other. Because if you look at all, actually also all the source codes are also in data. So you can still decide, even on the study basis, to do harmonization. So if you think the mapping is for a specific study, you can still fall back to the Christel and Miriam suggested, where you will make per data source mapping. So one doesn't have to exclude the other.
Miriam, would you like to comment, please?
No, I fully agree with that. So it doesn't need to exclude Dutch, but then what is the value of having spent 6 to 12 months to do the upfront mapping?
Because, well, we've demonstrated that I think with the study that we Maxim, that for most of the studies, we are able to run them much faster. If you do it once, you will both contract once you are much more proactive. Questions that come that react. When stuff comes in, we immediately start then doing another.
So please, go ahead.
I just want to pick up on that point, and you were set the point you made there about time duration. One thing we found in the following the various calls and the data models is actually the time to ETL is accelerating further. There's a number of factors involved. But of course, it becomes self-perpetuating because you're learning as you go all the time. Of course, you also share scripts and share the ETL designs and so forth. So you can accelerate quite a lot of this process. I think it can improve and articulate this with good quality over time, particularly as you kind of industrialize it with a large number of data parts as well.
Especially also because of very large, as the example of friends that we showed, very large number of the codes are actually mapped well, and those are.
Thank you. I don't know whether Christel is still online, but I would ask final comment to Andreas, please.
Final comment. Okay, I'm on spot now. Well, I think I pushed a little bit on the data curation side because I think this is also for me a point why I would do at source doing certain aspects from the very beginning, because yes, we can do later on quick and do mapping again and again, but then we are cleaning up the same errors again and again as well. So I think it's very hard to find people who would like to do the job, and it's a boring job, let's be very honest. So if we could do this balancing that we sort out the problems early and still keep the flexibility. If that's a good last word, then this would be my 5 seconds.
Thank you, Andreas. And thank you.